Welcome to Spring LIB.
Our question wants us to consider a wire which is broken into section 1 and section 2 based upon figure 26-29. Section 1 has a diameter D1 which is equal to 4.0 R, and section 2 has a diameter D2 which is equal to 2.0 R. It says the wire is copper and it's carrying a current. So this current is made up of electrons. So we know their charge E is 1.60 times 10 to the minus 19 coulombs. It says that the length of the wire is 2 meters, so that's L, and the potential over the wire V is 10 microvolts, so that's 10 times 10 to the minus 6 volts, so that's V. And it wants us to figure out the drift speed based upon this if the number of charge per unit volume N is 8.49 times 10 to the 28 per meter cubed. Okay, well, also, since the wire is copper, we know that rho is 1.69 times 10 to the minus 8 ohms meter, and you can just get that from table 26-1. So using equation 26-10, which says that the current density J is equal to the electric field divided by rho, clearly we need to know the electric field because we already know rho. Well, the electric field, E, is equal to V divided by the length over which that potential is being applied. So if you use that, we can then plug that into, since we know both of those values, we can then plug that into this expression, J2, and we can get the charge density in section 2, which would be E over rho, which is equal to 296 amperes per meter squared. Okay, since conservation of current between section 1 and 2 is applied here, J1 times A1, so that's the current in section 1, has to be equal to J2 times A2. Let's write that A a little bit bigger. And since D1, if you notice above, D1 is equal to 2 times D2, and area goes as diameter squared, area 1 is going to be equal to 4 times area 2, right? So if we know that's true, we can plug that in, and J1 will be 1/4 J2, which we just calculated. Therefore, J1 is equal to 74 amperes per meter squared. Now, using this expression and the fact that J is equal to the voltage, the drift velocity divided by N, not divided by, is equal to N, the number density, charge E, times the charge E, times the drift velocity. We can use that to then calculate the drift velocity. We'll do that on the next page here. So V sub D then is equal to J1 divided by N times E. So you plug those values into this expression, it comes out to be 5.44 times 10 to the minus 9 meters per second. We can box that in as our solution.